Thank you. Thank you. So, in our introduction class, so we have seen about our syllabus as well as what is thermodynamics and what are the applications of the thermodynamics. And for the prior knowledge, we have seen these all like gas turbine engine and steam power plant and even automobile engine and even your refrigerator or air conditioner. Okay, how those works that we have seen. Okay, and also we have discussed a little about what is thermodynamic system. Okay, but anyhow, I'm again freshly starting from this point. Okay, so I think I have added all the students. Okay, if anybody is missing, please send me a message in the Teams itself. I'll add. So far, I think 69 students have registered for this course. Okay. Yeah. Now, what is thermodynamic system? You have very well studied about your mechanics. Okay. Whatever the body you are taking, that could be a mechanical component like a truck applying forces. Okay. Or any bolt kind of thing applying different sides forces. Okay. Or dead weight applying different forces. Okay. Like that you might have seen in case of your mechanics. What is the system over there? Whatever the component upon which you are applying different forces and you are trying to solve the problem, that itself is your system over there. Okay, that you are considering it free body over there. In case of our thermodynamics, we are considering whatever the geometry or whatever the volume, okay, or whatever the mass we are focusing upon to characterize thermodynamically, that is our system. Yes, this you are doing in case of your mechanics. Okay, in case of thermodynamics, this is the space or region or volume or mass, anything it could be. We are considering it as system. Okay, and then here, apart from the mechanics orientation, here we have to define some other things also, because thermodynamics means the heat is involved in this, energy is involved in this, work is involved in this. Okay, and even the flow is also involved in this. These all might be crossing the system. Okay, or entering in the system or leaving in the system. Okay, something is happening. Okay, so that's what. Along with the system, we have to define certain other things also that we can call this is. Okay, that we can call it as boundary. Whatever outer surface of your system is there, that we can call it as a boundary. And this is your system, this is your boundary. Then what else? Obviously, surrounding is surrounding. Okay, as like your home, you have your home, around that you have your compound wall. Okay, that compound wall itself we are calling boundary wall. Yes, that is your boundary. Whatever the space inside you have, that is your space, we can consider it as a system. Okay, beyond the compound wall, outside, all are surrounding. Okay, even we can say sometimes our surroundings, sometimes we say our neighbors. Okay, the synonym of neighbors we can say our surroundings. Like the same philosophy, nothing great. This is the system, this is boundary, this is surroundings. Okay, now let us see. Here, in case of your system, sometimes mass is coming in, mass is going out. Okay, yes. Sometimes energy is coming in, energy is going out. Okay, that's what we have to define what kind of system it is. Okay, what kind of system it is. Suppose see, In case of your bathroom geyser, you have right. The water is coming from the overhead tank and you are taking water to the bucket for your bathing. Yes. The mass is, let us assume the system is your geyser or electric heater. Okay. The boundary is anyhow the imaginary boundary surrounding it. The water is crossing the boundary and entering the system, the cold water. The hot water is leaving the boundary and draining into the bucket for your bathing. Okay, like mass is crossing the boundary. Okay, mass inlet is there, mass outlet is there. Okay, same like energy also. Okay, so let us see. You have cooked food. Okay, then you have off the stove. Okay, then after 1 hour, what will happen? Obviously, the food temperature is comparatively relatively less. Yes, what happened? Mass is not transferred. Your food is still there in the vessel only, but energy is transferred. Yes, like that. Okay. So if you have system, energy will be crossing the boundary and also mass will be crossing the boundary. Based upon that, we have divided the systems into closed system, open system, and isolated system. Okay. The closed system means this we are defining based upon the mass. Okay. Closed system. In case of the closed system, mass not crossing the boundary. Okay. Mass not crossing the boundary. For example, let us see over here. We have explained the automobile engine. Yes. In our previous class here. Okay. What's happening over here? This is your suction stroke. That time this valve is open. Whatever it is, air or fuel or otherwise air fuel mixer, both are coming inside. Okay. When it is coming, when this piston is reaching up to this position. When piston is moving up, that time this is closed. Here both the valves are closed. Okay. Here. Okay. Now the same example. Both the valves are closed. Now piston is moving up. What is happening over here? Whatever this charge is there over here, this charge is compressing. Okay. But no mass transfer is existing over here because both the valves are closed. This kind of system we can call it as closed system. Okay. In case of the open system, okay, in case of the open system, when you take complete engine as your study, when you take complete engine as your study, continuously air is entering to the engine, exhaust gases are coming out of the engine. Yes, or otherwise, as our previous example, water geyser. Okay, cold water is entering into the system, hot water is leaving from the system. Okay, that is your open system. Okay, then isolated system. Okay. This is not interacting with surroundings. Isolate. Okay, okay, that is your isolated system. These are simple definitions. Okay, that is. And now, in case of thermodynamics, we have two different studies. Okay. The first one is macroscopic and another one is microscopic. Anyhow, our study, engineering thermodynamics, is macroscopic study. Okay, we are not going microscopic study. That means macroscopic study means our concentration is overall concentration. Okay, like this is total system, air is entering, air is leaving. Otherwise, here also some compression is happening, some energy is releasing or energy is absorbing. Like that we are studying. But we are not focusing upon within the gas when we are compressing. This gas is actually a combination of many things. Maybe fuel is there, maybe air is there, and again air, oxygen is there, nitrogen is there. Okay. In the individual component, what is happening? That is obviously we can say microscopic study. Yes, microscopical. That means in depth we are studying. Okay. In case of macroscopic, we are studying overall system. In case of microscopic study, molecular dynamics also we are studying over here. Okay. So that's what this microscopic thermodynamics, we can call it as statistical thermodynamics. Okay. All engineering application oriented thermodynamics are macroscopic thermodynamics, or we can call it as classical thermodynamics. Statistical thermodynamics means, as we have mentioned, okay, individual component we are studying. That let us see. Okay, see here. This is even our own paper only. Okay, example of microscopic thermodynamics is studying about chemical kinetics. This is simple example. We are burning over here C4H10 means butane fuel, okay, in presence of air. Okay, so here in the reaction 50 different species are forming. Okay, in the reaction when you are burning butane plus air. Butane means what? Your LPG itself, whatever you have in your home gas stove. Okay, there actually 373 reactions are there, 50 different species are forming. Now, this study is about how each species is behaving. When temperature is changing, when pressure is changing, okay, when concentration is changing, then how its reaction also changing. Okay, suppose whatever reaction we are showing over here, reaction 532, okay, this reaction is happening with certain operating parameters. If you change your operating parameters, this reaction may or may not be happening. Okay, if happening also, its intensity would be something different. Okay, that is about microscopic study individually about each element within the system. Okay, this is just for example. Okay, no need to worry about what is this much of this much of this much. Okay, just for example. That is about what is the system, what is boundary, what are the surroundings, what is the open system, closed system, and isolated system. And then we have seen what is the macroscopic and what is the microscopic. Okay, our classical thermodynamics and statistical thermodynamics. Now let us move to a different set of topic, that is a property, state, and process. Okay, property means these all are what I earlier mentioned. We are studying macroscopic. That means classical thermodynamics. Okay, macroscopic property. That means the particular characteristic of the system. Okay, like what is your weight? Okay, what is your height? Okay, like that. Whatever the system is there, at that instance, whatever the instance, okay, its property we are mentioning over there. Such like the system has 4 kgs of mass. Somebody's mic is on. Can you please put it in mute? Okay, thank you. Okay, that system has mass of 4 kg, or that system has volume of 1 meter cube. Okay, or otherwise, if it is 1 bucket of water, hot water, that water temperature is 70 degrees centigrade. Okay, the water capacity, the bucket capacity is 20 liters. Then simply you can say what energy it has. That means M specific heat of water and delta T of temperature. Okay, that is the energy it possesses at that instance. Why I am mentioning at that instance? Suppose after 10 minutes, the water temperature may be going down. Okay, then energy will be changing. Okay, and even the pressure, like your cycle tube pressure. What is the pressure? Today maybe pressure is sufficient. You are happily riding your cycle. After 2 days, because of some minor leaks, you continuously leaking. Then you have to pump. Okay. Even car tire. you will be inserting a pressure gauge and you will be measuring. For case of cycle, what you are doing, you are simply pressing by hand and you are judging whether it is sufficient or not. Okay, in case of the car, we cannot do that. So we are inserting one gauge and we will be measuring. That means property means a macroscopic characteristics of such a system at that instance. Okay, maybe temperature. Okay, like your coffee. Okay, coffee just boiled upon the stove. Okay, and then you have, excuse me, and then you have poured in your cup. That time, what is the temperature? Like boiling temperature of water. Okay, after 5 minutes, it could be reaching to 80 degrees centigrade. Yes, like that. These all are the properties of the system. Okay, or otherwise, sometimes we can say it as characteristics of working substance at that instance. Okay, nice. In these properties also, again, two different classifications are there. That is like extensive property and intensive property. Okay, extensive property and intensive property. Let us see what are those. The extensive properties means when you are separating it, certain volume is there, suppose. Okay, or otherwise certain system is there. Let us not consider volume now. Whatever the property means, we are indicating the characteristics of the system, right? That system you are dividing. Okay, if that property is changing, then that is extensive property. As like, see, you have certain mass, that is 5 kg. Okay, now you have, that is totally 5 kgs of grain in one bag. Now you have divided into two halves. Okay, then what is the mass? Mass is varied, right? That is not fixed. Mass is varied. Yes, and also you have volume wise. Okay, one bucket of water, half bucket you have poured out. That means volume is changed. Yes, when you are splitting the system, if the property is changing because of the splitting, that property we can call extensive property. Okay, so because here we have shown here extensive properties are these two. Intensive properties means it is not changing even though you are splitting. For example, now you have boiled the tea. Okay, big kettle of tea for 10 people. Okay, boiling means it is at boiling temperature of 100 degrees centigrade. Then you want to serve to all the people. So you have poured down to 10 cups. Okay, so that means your temperature is dividing by 10. Obviously no. The temperature is same like every container, means every cup, as like earlier in the big bowl or boiling bowl. Is it like that? The same like that. The same example is the density changing when you are dividing that big vessel of tea into the 10 cups? Not. Okay. So when you are splitting the system, when its property is not changing, okay, then that is intensive property. Like this. Even this is the example we are giving. Okay. This is the whole mass. When we are dividing into the mass, different parts, okay, its mass is changing. Okay. Like that. Here even whatever the extensive properties, whatever the intensive properties, all are summarized here. Okay, you can read it. Okay, now specific extensive property, okay, becomes intensive property. Okay, that means this by kg. Okay, that is the specific properties. Dividing by mass is the specific, right, per kg. Okay, those all are intensive properties. Okay, that is. Now we need to identify state of the system. Why we need to identify state of the system? When we are talking property over here, okay, what I have mentioned, Many times I have mentioned at that instance, at that instance, at that instance. Yes, that means in the time, okay, that property might be changing. Yes, with the time property might be changing. That means some changes are coming in the system. Okay, that means state change is happening over there. Okay, how the state change is happening, let us see. Suppose see, at the state one, okay, this is the container. We have 2 kgs of mass. Okay, that is O2 gas, obviously. Okay, at the pressure of 500 kilopascal. Okay, and at temperature of 60 degrees centigrade. Something happened. Same mass. Okay, same mass, same gas. Pressure increased to 700 kilopascal. Okay, obviously once pressure is increased, temperature is also increasing. Okay, this is state 1, this is state 2. Okay, now question is, do you have any intermediate states over there? Obviously we have many. Otherwise, all of a sudden how it can jump from this to this? Okay, obviously we have many intermittent states between over here. Okay, that let us see. Suppose this is the piston and cylinder. Okay, the aim of this piston and cylinder is to compress the air as like your whatever the cycle shop or otherwise automobile shop. Okay, air compressors are there, right? That kind of compressor, let us assume. Okay, this is the initial stage. Okay, this is the initial stage. Let us consider this is the initial stage. Now it is moving like that. This is Px. That means see, this is P1, V1. That means pressure is 1, volume is 1. Okay, this is Px, Py. Pressure is changing, volume is changing. This is P2, V2, final stage. Okay, this is the final stage, P2, V2. Okay, in between the journey from P1 to means initial stage to final stage is like this. Okay, it is like this. In between, it is passing through many number of states. These all states we can call it as intermittent states. Okay, intermittent states. Here actually, volume we have not mentioned once you observe. In this case, state 1, state 2, volume we have not mentioned. We mentioned in terms of mass. Okay, here also mass is same. Mass is not leaking at that. Okay, volume is changing. Because of that only pressure is increased. So that is the reason. This is the PV plot. This y-axis is pressure, x-axis is volume. Okay. When we are compressing, pressure is increasing, volume is reducing. Okay. Pressure is increasing, volume is reducing. This is about what is the initial state, what is the final state. These are the intermittent states. Whatever this line is there, right, reaching from initial state to the final state, this we can call process. Okay, this we can call process. Even we have different types of processes. Okay, those are let us see later. Now we are going to learn another word over here, that is thermodynamic cycle. What is thermodynamic cycle? See. A process fluid undergoing in many processes, okay, and then coming back to the initial stage, okay, that we can call it as cycle. Okay. Suppose see, this is your steam power plant. We have discussed that this particular image, yes, that time in the introductory class. Now here we are showing this in terms of line diagram over here, schematic diagram, and also we are showing process diagram also over here. Okay, so let us start from boiler. And let us assume this is the boiler process 2323. Okay, In the boiler process, this is the constant pressure process. Okay, heat addition is happening over here. Okay, that is. Then that fluid is expanding upon the turbine. This is the turbine process. The same steam. Whatever the steam becomes superheated steam in case of the boiler. Okay, expanding upon the turbine. When you are expanding, because of that, turbine is generating certain work. This work will be our useful work. Okay. Then from the turbine, it is going to the condenser. Okay. As I have explained you what is the purpose of condenser. Okay. It is condensing. It is changing the phase. Okay. So for what is the phase over here? This is the steam, means gaseous stage. And even here also this is the steam in the gaseous stage. In the condenser, it is condensing to the liquid. Okay. That is this process. 4 to 1. This is condenser process. Okay. Then this is the pumping. Okay. Because expansion means here itself you can understand pressure reduced over here. Yes. Pressure reduced. Now boiler is running at high pressure. Okay. From the certain device is required to pump the fluid from low pressure to high pressure. That is your pump over here. Okay. Here it is water again. This water is reached to the boiler. Yes. And again it is changing its phase in the boiler, becoming steam and impinging upon the turbine. Okay. And coming back to the condenser and changing its phase to the liquid. And this pump is again pumping back to the boiler. This is only the cycle happening whenever you are running your steam power plant or thermal power plant. Okay. So whatever this is there, right? This we can call it as cycle. Okay. Cycle. In the cycle we have many processes. Okay. Those all process, it is not required to be same processes. Okay. This process is constant pressure heat addition. This process is isentropic expansion. This process is constant pressure heat rejection. This process is constant pressure compression. Sorry, constant entropy means isentropic compression. Okay. This is isentropic expansion. This is isentropic compression. This is constant pressure heat addition. This is constant pressure heat rejection. Okay. Different processes I am telling. Combination of all the process. This is combinedly we can call it as cycle. Okay. Okay. Fine. So what all we have seen so far? System, different types of systems and properties and states and cycle. Now, equilibrium. What is equilibrium? In case of mechanics also, you might have seen. What you have seen? If there is a component is there, in the x direction, y direction, z direction, okay, all forces are, net forces are equalizing and some becoming zero. Okay, then component will not be moving from there. Yes, that is mechanics saying over there. In your first year mechanics, you might have studied. That means when all directions, net forces, applying forces are becoming zero. Okay, all sum of x directions are zero, all sum of y directions are zero, all sum of z directions are zero. Then component is not moving any direction. That is the equilibrium state we have defined over there. Okay. That means no interaction. Simply to say no interaction. The same like that in case of thermodynamics also, it is reaching to the stable state, stable stage. Okay. That is equilibrium. Okay. But there actually in case of the mechanics, what we are studying over there in terms of forces only, otherwise nothing. Okay. But here, this is the thermodynamics, right? We have many things over here. Okay. Like pressures also we have. Okay. Forces we are applying. Yes. Pressure is the pressure change is there means force change is also there. Yes. And even temperature changes are there. If temperature changes are there, what will happen? Heat transfer will be happening. Okay. Suppose a hot pan is there on the stove. Okay. When you are keeping your hand close to that, you will be sensing hotness. Okay. Heat transfer is happening. Okay. Then even phase changes may be happening. Just now we have seen where liquid to gas, gas to liquid in case of thermal power plant, phase change. And even chemical equilibrium, when chemical equilibrium is coming into the picture, as we have explained in our introductory class, when you are burning the fuel, that chemical energy is forming to the heat energy. Okay. Chemical energy is turning to the heat energy. Okay. So that is also happening. Thermodynamics means combination of these all, like mechanical because of the pressure differences, like thermal because of the temperature differences, like phase change because of the fluid changes, and chemical equilibrium because of the chemical reactions like combustion reaction. Okay, these are. When the system is thermally means equilibrium state means no changes are happening with respect to these all. Okay, no changes are happening with respect to these all. Okay, like even see coffee. Okay, you left the coffee. Okay, then what will happen? It's keep on exchanging the heat because this is the hot body, surroundings are cold, keep on exchanging the heat. After some time, let us assume after 2 hours, what will happen? This is also reached to the environment temperature. Then nothing to share. Yes, nothing to share. That means this is in the equilibrium condition. Okay. So, but in our study, we are considering whatever here we have seen, this state and this state, we are considering actually reach to the equilibrium condition. Okay, but practically it is not possible. Okay, so when it will be possible means when it is quasi equilibrium. That means quasi means almost slow. Okay, slowly. Whatever the interactions are happening slowly. Okay, but in case of all the processes, is the process are happening rapidly or slowly? So your internal combustion engine is there. Internal combustion engine is rotating at 1500 RPM, means revolutions per minute. In one revolution, okay, two processes should be completed. Okay, 1500 revolutions per minute. Within that one revolution, two processes should be completed. How fast it is? Yes, but still sometimes we are assuming. Okay, reaching to the equilibrium condition. Let us see over here difference between quasi-equilibrium and non-quasi-equilibrium. See, here this is a piston and cylinder compression system. Okay, you are compressing it very rapidly. Okay, what will happen? The pressure near to this piston will be high, then less, completely less. Okay, means pressure wave is like this. Okay, when you are compressing slowly, then what is happening? The communication between the molecules is very good. Okay, and almost equal pressure gradient is existing over here. Okay, that is different between these two. This information is given over here. Okay, so I'll be sharing this presentation. Once you study in detail, okay, then you can understand. But thermodynamics means you have to understand actually by slowly reading the content. Okay, please try to understand. That is the same text, whatever we have given over here regarding the previous thing. Now, we have mentioned that what is the state, what are the properties. Yes, once change is, the state is changed, then properties are changing. Yes, once state is changed, from state 1 to the state 2, whatever the example we have shown, in between many intermittent states also there. Okay, at the state 1 pressure is P1, volume is V1. Yes, its temperature is T1. When it is moved to the state 2 by following certain process, then its pressure is P2, volume is V2, temperature is T2. Yes. So these are all the things, whatever properties we are mentioning over there, we need to measure them, right? We need to measure them. That's what we need to see what are those actually. Okay. So all the measuring system as you have practiced in case of your class 11 and class 12, we are converting towards mass, length, time. Okay. And also in case of force. Okay. This is the system. This thing you know very well about that. Okay. However, regarding that, I have given you certain information over here. Okay, that you can please read. And even this is the unit system, whatever we are seeing. Yes. And even this also, you know what is tera 10 power 12, what is pico 10 power minus 12. Okay. What is kilo 10 power 3. Yes, what is milli 10 power minus 3. Okay. This is the information I have given you for your knowledge. Okay. So not required to discuss these all things because you know very well. Okay. Now let's come back to again thermodynamics topic like continuum. Why should we worry about continuum? Continuum means simply it is continuity, degree of continuity. Okay. See, if it is solid, then you know it is one continuous structure. Yes. If it is solid, one continuous structure. If it is a liquid and also you don't have any doubt, then each molecule or otherwise, whatever the content in case of that liquid is connecting each other. Okay. In case of the gas, you might be having doubt. Okay. All together or not. Okay. So that is suggesting about continuum. Okay. That means homogeneous matter with no holes, that we can call it as continuum. That means continuity. Okay. Suppose you have gas in one particular vessel. Yes. Gas means those all are with molecules. Okay. Even each molecules are separated. Yes. Each molecule are separated. But still we are considering it as homogeneous matter. Okay. So because see, this much of small volume of 1 millimeter cube. 1 millimeter cube means very small. Yes. Like your pen tip. Yes. 1 millimeter cube. These many molecules of oxygen. This is the oxygen content actually. This is the oxygen gas. Okay. These many 3 10 power 16. Okay. These many molecules are packed. Where? In case of 1 atmosphere actually. If pressure is increased, then molecules will be increased more. Number of molecules will be increased because pressure is increased means compactness is increasing. Okay. Compactness is increasing. Yes. That means why should we consider continuum? Whenever you are measuring certain property, okay, whenever you are measuring certain property, we have to believe that this particular substance is continuous or homogeneous or it is under continuum. Okay. Then we can imagine that when you are measuring certain property over here, the same is over here, same is over here, same is over here, same anywhere over here in this particular volume. Okay. Suppose see, this is your tire. Okay. Your car tire. Then you will be inserting your pressure gauge. Okay. Where? At the valve. There you will be measuring, that is showing you 30 or 35, whatever the unit that is. Okay. Yes. So we are believing entire tube or entire tire the same pressure. Okay. Obviously, because that is homogeneous matter and following continuum. Okay. Now, basically we are defining over here three basic parameters or properties. One is the specific volume, pressure and temperature. Okay. So pressure and temperature let us discuss in detail. Specific volume is nothing. Okay, volume per kg. Okay, volume per kg is the specific volume. Okay, so we have elaborated over here very well. Okay, that you can see, or otherwise reciprocal of density. Okay, density is means what? Mass by volume. Yes, here specific volume is reciprocal of density. Okay. Now the pressure. Yes, what is the pressure? Force acting upon unit area is the pressure, that you know very well. Yes, force acting upon unit area is pressure. Then we are measuring in case of pascals. 1 Pascal is Newton per meter square. Okay, Newton per meter square. Then here the pressure measurement. Now the thing is, you have gone to the puncture shop, okay, whatever patch shop we can call, automobile shop. You want to measure your tire pressure. Okay. Then he will be bringing the gauge. What is the gauge showing initially? What is the gauge showing initially? 0. Okay, like this, like this. Yes, it is showing 0. That means what? This is in the, this port is open only. Here the port is there at this corner. Yes, the port is open. That means this is the measuring device for the pressure. Okay, this is obviously measuring the environment. Yes, that means environment pressure is 0. No, we have certain pressure. Yes, 1 bar we can call. Yes, we have certain pressure. So that's what here we have defined. This is the gauge pressure. Okay, gauge pressure is 0. Whatever the environment pressure is there, okay, that pressure we are considering it as atmospheric pressure. Atmospheric pressure plus gauge pressure once you consider, that is your absolute pressure we are taking. Okay, that is when in case of positive side. Okay, that is positive side. Gauge pressure plus atmospheric pressure is absolute pressure. And also we have vacuum also. Yes. So in case of the vacuum, in the reverse concept, okay, this also you know very well. Yes. And now, suppose see, this is the dam. Why the dam structure is like this? Why not be a straight wall? Okay, straight wall with this thickness, or otherwise why not a straight wall with this thickness, bottom thickness? Why dam wall is like this? The reason is there. This is the water. Okay, pressure we are defining rho GH. Density of the water is same. Okay, 1000 kg per meter cube. This is obviously gravity. Okay, with increasing the depth, pressure is increasing over here. Okay, here pressure is less, here pressure is moderate, here pressure is very high. Wherever pressure is high, force is very high. Yes, to sustain that much of high pressure, maximum material is required. That's what it's increasing the pressure. Material also added over here. Yes, this is about understanding the pressure. Then we can measure the pressure in different ways. Okay, like this is the manometer. Okay, this in previous semester you might have solved some questions in case of your fluid mechanics also. Yes, just previous semester. This is the manometer. We are using different liquids over here. Okay, this is the manometer liquid. Okay, whatever this difference is there, L, then we will be applying this particular formula rho GH or rho GL. Yes, then we are measuring what is the pressure difference. Here, this side is atmospheric pressure, this side is tank. Okay, then that is giving you the pressure difference. That means gauge pressure, it will be giving you the gauge pressure. So let us assume instead of connecting to the atmosphere, this end is connected to the other vessel which has certain different pressure. Okay, then you will be finding out difference between both the pressures. pressure difference between both the tanks. Okay. Whatever rho GL is showing a difference between pressure of both the tanks. Okay. That is about this. And one more thing is what kind of fluid we should pour over here in case of the manometer liquid. Okay. See, many times we are using mercury. Okay. Because the pressure is showing over here rho GH. Okay. So let us assume here this is 5 units over here. Okay. 5 units. Then I would like to change this liquid. Earlier it was mercury. Then I am pouring certain other fluid which has half of its density. Then what will happen? This column length will be increasing. Okay, because this side is 5 units, right? This is off. Then this should be double. Yes, that's what. Whatever the high density possibility is there, that liquid we will be using. Fortunately, we have highest density when compared to the metal also, but still that is in the liquid stage. That's what I am telling fortunate. That is mercury we have. Okay, that's what we are using mercury in these cases. Okay. And apart from this YouTube kind of manometers, we have some other devices also like this thing, Bourdon pressure gauge. Okay, this is Bourdon pressure gauge. On what philosophy Bourdon pressure gauge works means this green tube is there, right? When certain fluid at high pressure is passing through this green tube, okay, this tube itself is expanding. Okay, when it is expanding, this edge is moving this side. Okay, same time, this is moving this pinion gear. Okay, obviously, the pinion gear is connected with this particular pointer. Okay, the pointer is actually given to the dial gauge. Okay, according to the earlier calibration, it is showing you the pressure. On this category, it is working. Apart from these conventional methods like YouTube manometer and bit advanced version is like a Bourdon pressure gauge, we have some other gauges also like piezoelectric effect. Okay, there are sensors inside. Okay, electronic sensors. Okay, then pressure is changing accordingly. It is generating certain voltage. Okay, then according to the pre-calibration, then respective voltage and pressure is linked up. Then we will be measuring accordingly. Okay, that is about the pressure, what we are using, how to measure them. Now, temperature. Okay, temperature, and here actually we have a very important thermodynamic law. Out of thermodynamics, 3 laws we are discussing over here through the temperature. Suppose see here, you have hot body over here, and you have another cold body over here. Yes. Then when heat transfer will be taking place, when hot body at high temperature, cold body at low temperature, both are in contacting with each other. Okay, temperature gradient is existing. That is the reason heat flow is happening over here. Okay, after some time, what is happening over here? Let us assume after 1 hour or 2 hours. By heat transfer is happening continuously. Okay, the hot body temperature is reduced and cold body temperature is increased. Both have reached to the one uniform temperature. Okay. Furthermore, there is no heat transfer between both. Okay, that means both reach to the equilibrium stage, thermal equilibrium stage. Okay. Now here, suppose I have body A. Okay, and then I have connected body B with A. Okay. Now let us assume body A is at high temperature. Okay. Then let us wait for some time. What will happen? Obviously, heat will be flowing from body A to body B. Okay. Both will be reaching to the thermal equilibrium. Okay. Now, what I have done, this is high temperature body A. I connected body B. Immediately I connected body C with B. Okay. 3 are in contact with like this. Okay. Now heat transfer is happening like this. A to B, B to C. Okay. That means after some time, okay, all will be reaching to certain equal temperature. Okay. It is not required A should be in contact with C or C should be in contact with A. Yes, heat flow is happening like this. Okay. So that we are expressing over here. If you see here, when two bodies are in thermal equilibrium with the third body, okay, they are in thermal equilibrium with one another, which is sometimes called zeroth law of the thermodynamics. Okay, zeroth law of the thermodynamics. This is zeroth law of the thermodynamics. In other way also, it is explained over here. Okay, developed by the great scientist Aristotle. Okay, in 1931. Okay, this is zeroth law of thermodynamics. Based upon zeroth law of thermodynamics only, we are able to measure the temperature of any substance. Yes, temperature of the any substance. What you are doing, certain fluid is there, or bucket of water. You want to measure the temperature of the hot water. What will you be doing? You will be bringing thermocouple and keeping it. Yes, yes. Then what is happening? The thermocouple, the point is suppose a glass or otherwise a metal. Okay, inside what you have? Mercury you have. Okay, that mercury is slowly expanding. Wherever at whatever the temperature, it is stabilizing over there. Then you will be saying this is the temperature of the water. Yes. When it is the mercury is slowly moving up, moving up, moving up, you will not be judging the water temperature. You will be waiting for certain temperature. Means certain time. When the mercury is not further moving, that is the case of conventional thermometer, mercury thermometer. Or otherwise, nowadays you have electronic thermometer to measure body temperature. Okay, you want to measure whether you have fever or not. What are you doing? You are taking that thermometer, you are putting anywhere in your body. Okay, and then you need to wait a couple of minutes, or otherwise at least 1 minute or 1.5 minutes. Then it will be giving you beep sound. Point. Yes. Then you will be finding out. You will be taking out and you will be seeing the screen. That is the temperature. That means what? Your body, the outside material of your thermometer and inside thermometer fluid, all three are reaching to the equilibrium. Okay, once it is reached to the equilibrium, then you will be judging its temperature. Okay, that means whatever the great philosophy you are using from the long time, measuring the temperature of any substance by using thermocouple or thermometer, okay, that is derived from zeroth law of thermodynamics. Okay. Okay, so that is about today class. So let us discuss tomorrow. Okay, thank you. Thanks a lot. If you have any doubt, you can write in our Teams itself. Okay, so we will be giving you answer whenever we have some time. Okay, thank you. Yeah, thanks a lot. Thanks a lot.
Thank you,
Thank
sir.
you, sir.
Yeah, fine. So I'll be sharing this presentation by evening. Okay, thank you.